Hi. Um, uh, Today we are going to start mobile technology topic. Particularly, we need to set up um, apps development environment for iOS operating systems. Um, iPhone apps, more generally, um, iOS applications are built based upon MVC model. What we will look at maybe today, if not next week, what NBC model is. This is a basic underlying architecture that we can build iOS applications. The language that we are using, or we have been used, is Objective-C, but actually uh, right now uh, we are using uh, the language that is extended from Objective-C. This is Objective-C, the language that has been evolved. Oops, let me use this. Evolved a little further. That is a so-called Swift. Swift is much more powerful. At the same time, easier than Objective-C. Um, Easier means at the first few stages of developing iOS apps, you can understand the language or the control mechanism of iPhone apps very easily. But if you want to maximize the utility or capabilities of iPhone apps, toolkits that actually um, you may need to understand almost all the features of Objective-C. So for the time being, you do not need to worry about Objective-C, but as we expose Swift, uh, we all uh, get wet um, the world of Objective-C. Um, and also iPhone apps, not only Android apps, uh, are running on graphical user interface. So there's a interface, strong interface is running. So we need to touch upon all the features of graphical user interfaces. Um, so so we actually need interface builder, um, and and there are multiple objects are created. Some objects are based upon the class that we define or class already defined. Some of them are user interface objects. Some of them are business logic objects. So there may be multiple objects are created, and therefore we need to wire them up so that, for example, business logic objects may react to the graphical user interface objects um, it is very general and very natural. User uh, touch the iPhone screen in response to user uh, touch. Your business logic needs to be um, activating or triggering something. So that is the mechanism that you need to figure out. So what happens here is that you need to build some of the objects. Right? Some of them are graphical user interface, so that you may have some of the text field here, and some of the buttons, or some display panel, and behind this you need to have some objects. So this object may be able to be hooked up together with this graphical user interface and business logics. So what happens is that if you type this and hit enter, or when you click this button, accordingly there may be some other business logic is activated. So somehow wiring up is needed. It's very complicated as you imagine, but in real implementation, almost all things are pretty much cooked and ready for you to use. It's a lot more cooked than Android apps development. But still, you need to understand the concepts behind this development toolkits. There is a toolkit, IDE, integrated desktop environment. Xcode is available. So Xcode can manage and help you edit your code very efficiently, and also it can help you run your application program. All right. Okay. Oh, all disappeared. I don't know why, but anyway, so that is it. So some of you who heard of Objective-C or had experience about Objective-C may be wondering the difference between Objective-C and Swift. Um, it is okay even if you do not know Objective-C. It is quite okay if you still do not understand the C or C++. Swift is the only thing that you need to know at the beginning stage. But that is a lot easier. As it said here, Swift is easier to read. Okay, easier to read. There is no like C or Java ending symbols required. Easier to maintain. If it is a C, then you have to create header files and implementation file on all other files, but a lot easier here and safer. Usually C or Objective-C allows the nil pointer, so the cleaning up nil pointer is the programmer's responsibility. Having that, programmers could do much more, something beyond that we could imagine, but Swift is taking care of it, so you do not need to worry about it. Swift is unified with the memory management. Swift requires less code. You may see that a lot simpler code, especially for the user interface, UI program, graphical user interface. If you do this Java or Android apps programmings, you need to have, for example, multiple lines to make it available. But from my experience of both Android apps and iOS apps development, Swift requires a lot shorter coding list. I would say at best case maybe 1/10 the size of Android, or at least a half size. So a lot less work. It doesn't mean that you do not understand the concepts behind that. I want you to understand the whole development concept. Therefore, you can appreciate the Swift. Swift is faster. Again, if you develop Android apps on Windows, the emulation takes a lot longer. Sometimes you have to wait a few minutes to see the emulation. But here, maybe it is because partly because of Mac, but language itself is faster also. And then it listed even further fewer name collisions with the open source objects. Swift support dynamic libraries. Swift has a playground so that there is an interactive the coding mode is available. Those who have, for example, Python experience, then you may, I wanted to recall that there is a user interactive mode of Python programming. Remember that, therefore, if you run a Python with no Python script, then you may have this 3 greater than sign command line prompt. So after that, you can type some, right? This is a user interactive mode. Similarly, here in Xcode, there is a playground, so you can play on the playground to get some idea, and then you can come back to the implementation mode. So that is also possible. Particularly, we are going to play more on the playground, all right? So iOS 9 SDK is available. Once you download the iOS development framework, then you can implement the application for iPhone, first of all, iPad, iPad mini, watch, TV sets, almost all the gadgets and widgets developed by Apple's. iOS SDK includes Cocoa UI framework, which is stemmed from Objective-C. So still Cocoa UI framework is available. We do not need to understand fully. If you could, that's okay, but even if you don't, there's no problem at all. Xcode IDE is available global current version is 7.0.1. I think that's what I am working on right now. The programming language is Objective-C internally, but I mean, partially as you do this Swift 2, you may I mean automatic the coding list that can be generated from drag and drop of a programmer's activities. You can see some of the objective code. So when it comes to that, I will let you know. There are a lot of coding statements are automatically embedded. So that is pretty much Objective-C. Xcode can be downloaded from developer.apple.com/ios/download. Many times it asks you your Apple ID. If you do not have, you need to create. You need to sign up your own Apple ID. Therefore, you can download Xcode. That is free, so you can download it. And once you download it, then you can install on your Mac. If you do not have a Mac but working on Windows, then at least you need to have a VMware. Again, on your Mac, the installation is simple. Simply click on that download once, then you can see after you download, for example, let me see. Right, this is the Apple download website. There's iOS 9.3 beta 2. This is for Xcode. Okay, so that you can download it. Let's see, apps development. If you are working on iOS 9.2, then Xcode download page here, right? So that you can download Xcode 7.3, 7.2. So you can download it. Once you download, then it is downloaded at the folder of downloads, right? So once you have that Xcode somewhere here like this, Xcode 7.3 beta version .dmg, if you double click, then it works. At some points like this, Xcode is icon can be seen the desktop. So when you make double click, then it says first thing then you need to do is this installation mechanism. You can drag and drop on the application. It's very simple, right? Drag and drop on the application. Then you can see it on your application folder. Once you drag and drop on application, then you have Xcode beta version like this, right? So you can click one of these, double click, then you can see this. But I have this already, so don't worry about this. I'm going to close. Let me see if I have any other. I have another here, so I'm going to close this. Probably not. Therefore, if I do Xcode. Double click. Okay. So you may have this. Well, actually, let me tell you one thing. All the download process and installation process, I simply speak verbally. I'm not showing you all the procedures, partly because sometimes it takes time consuming, but I want you to do that. There's no trick at all. Simply you download it, and then it is on your download folder. Open it up and double click on that DMG file. Then you can see that is installed on your desktop, and double click this. Then first thing that it asks you to do is to bring that up on your application folder. Once it is on application folder, as I did here, as I make the double click here on my application, you could do, then this is the first window. Let me close the other also here. So this is the Windows. If you see here, this is the application that I tested a little bit. Don't worry about this. You may not have this, but we'll create some of those. Three possible entry points that you could start. First one is get started with a playground. But actually we're going to play on a playground today. So from next week we'll do some project, Xcode project. Okay, so we'll do this. If you want to do some existing project that you already had, you may click this. All right. So this is what we want to do. But meanwhile, I'm going to, let's take a look at this. Xcode storyboard facilities, facilities and playground. Playground, that is what we want to work. The storyboard can be seen if you start working on project. Okay, so it is very similar to the case of Python. When you run Python for user interactive mode, then that is nothing but the playground, in this case Xcode. In Python, if you want to develop some program, then you need to edit it using any editor and make a file, and you need to run that file. So all the editor is needed, right? Well, this is Xcode. Anyway, we can take that advantages here. And by clicking this Xcode project, then we will have some of the storyboard. What storyboard can do is that it gives, through that we can set up the app's layouts. Okay. The components that we can use for laying out for your application layout includes some of the graphical user interface components, like text field, button. There are all kinds of different types of buttons, and some labels, all kinds of labels again, and they need to communicate with each other. So you will have storyboards. Storyboard is like a canvas, big canvas that appears on your iPhone, one screen. So you can populate some of the graphical user interface on your screen. Each components can do some functionalities, and it may access or communicate with others internally or externally. So all kinds of activities need to be implemented. Okay. So if you look here, Xcode IDE provides developers with a storyboard environment to plan and design program flow structure and UI functionalities. On the other hand, so um, this storyboard uh, is part of a project development. Playground is for your test or get some train. So Playground was a new features in Xcode 6 and after, which allows program code to be compiled in a real time for the purpose of quick code tryout scenarios, testing and debugging. Current version is 703. It is also aid to code learning process by facilitating the testing mode. So Xcode gives you a user interface and logic and simulator. All right. Through the Xcode, then you can use a Swift language. Swift is easier than Objective-C, and this is the short difference. You can declare a variable, say message, with this initialized string. If it is a variable, you can start with the var. But in Objective-C, you may need some other symbols, star, and this, and then some other things. Okay, and as a string, NS is for news tab. So all things needed. So here we have the Swift, here Xcode. All right. So, all right, this is something else. What I need. So we may be ready. These two, Xcode and Swift, are running on operating systems, iOS. In your case, it's Yosemite, right? Okay, so let's just, start the playground. Well, I think, let's see. Okay, now we will do play on the playground. Okay, let's go to our Xcode. I want you to click on the playground mode, which is on top of this list. Click on that and name my playground, and you can say my playground 1 and next, and simply create. All right, this is the playground. As you can see here, by default, the UI kit is already imported. UI stands for user interface, so user interface kit is already here. And also new variable str is defined. If a variable is defined, then there should be the modifier var, and then initialization equal sign, and then real string. String. Hello playground. One thing is that we do not. It doesn't need any semicolon. Okay. apparently semicolon, this playground does not complain about it, but not necessarily. Okay, so that is the variable. Similarly, we can do, for example, variable number equals 5, and then we can say print number. Okay, that's fine. So number, enter. Let's see here. There is a another utility that you can bring up, so Windows can be manipulated this. If you click the left back and forth, then the left hand side there's a pane, we call that navigator pane. You can squeeze back and forth, and right hand side it is already clicked. I mean, here, this is for memory space, and then there is a utility pane. Okay, so there's another thing. In the bottom here, by clicking this, then you can see this is the output. All right. So actually, we do not need the utility pane. So I'm going to close this so that we have a wider screen. As you can see here, if you do print, then output can be displayed here. So far, up to here, when we do this, then you can see some of this here, right? This tells you that in memory, these values are stored. Okay, that's what it says. This is for variable. If we want to do for example, constant, then you can say let, and then num equals 5, then num is it's another variable, but that is a constant. But as you can see here, it still has number 5. Okay. If it is a variable, then you can change the variable. It's not anymore 5, but you can say number equals 7. Fine. So as you do that, here you have a space. As you do, then the number that you can print becomes 5. Okay, this is a playground. If you do num equals 7, similar to that, then there is an error messages, right? So why there's an error message is because you said you declared the num is a constant. What do you mean by constant? Constants means it shouldn't be changed, right? So there is an error. If we want to make this ineffective, then you can make a comment. So double slash will be a comment notation. As you see here, the first line, which is given. Okay, so this is the playground you can play with. So we have somehow such things can be, I mean, Swift language can be stated on the playground so that you can see how the language can work quickly, and immediately you can see uh, the behavior of that language. Okay, so Swift is in the context of other programming language, variable declaration, typing, and assignments possible that as we uh, looked at it. Program outlet and formatting is also possible. Generating random numbers, data structures, function can be defined, structure definition, and also class can be defined. I know some of you do not like the word class, the concept class, which is a main primary concept in object orientation. But anyway, that is uh, the one of the major concept. Swift and Objective-C, which are the language that we are using for iOS apps development, has a lot of classes already defined. What you need to do is simply use it. So in order to use classes, then you need to do instantiates. As instantiate, you may have objects, right? So uh, the class is defined and object is instantiated. All those concepts are heavily addressed in Java programming languages. So it cannot be ignored here in Swift, but is not all. That is something that you could do, but not necessarily. Okay, so variable declaration in programming constructions. Um, so it's very much like other languages. But one thing is that is a loose typing, which means um, as you declare a variable, Swift language do not ask you to define the size of a memory space. For example, in Java, if you want to uh, declare a text, then you need to say string and variable name. If that is a 4-byte long number, then you need to say int. If it is a small number, then you need to do small, double, then double, and then variable. And what it does is that all the size required by a variable should be defined. But here in Swift, you do not need to do. We call that loose typing. Uh, as you already noticed, as you do string, this is a variable. It's not necessarily string. Just any variable. Okay. There's any variable here. You didn't say here the size of that variable. For example, in this case, a string. In this case, integer. That is a common declaration in Java, but it's not going to work here in Swift, which means you do not have to worry about it. Therefore, this is more flexible. Okay, that's what we had here. Um, so simply a variable, the label itself, and then you can say, oh, that is a variable. You do not have to say that is integer variable. or string variable. You could do it if you really need to. For example, like this. Variable, by the way, that is an integer. But it is not necessary. Okay? An assignment is one single equal sign, like many other programming languages. If we want to comparison, then there is a double equal sign. If there is a constant, then variable declaration is the same, but instead of a var, you need to say let. That is the keyword. If we want to print is a function, like a function. So print, and then within parentheses, you can say the string text. Output. By declare first number and second number if you want to add them by using this operator. Okay, and then you can assign the result into this new variable answer. So answer should be declared before you use it. Okay, and then if you want to print, well, actually ln is not needed. ln is an old version of the print statements in Swift, but Swift 2 do not need the ln, which means if you hit print, then automatically it gives you carriage return a new line. Okay, it's not like system.out.println or system.out.print. Println, therefore, it'll give you a new line. With the ln, then simply your cursor stops at the end of that print statements. But in new language of Swift 2, print behaves like println. So automatically it gives you new line. And therefore, if we want to keep staying on the same line, then you need to do something else. I wanted to think of, for example, Python. Then Python print statements there's a function also. Then it automatically gives you a new line. But at the same time, therefore, if you want to stay on the same line, then you need to say print. I wanted to recall this. Those who knows Python, print, and then you can say hello, mercy, double quote, and then function, so comma. And then if you want your cursor print staying on the same line, then you can say and equals empty string and close, then it'll stay there, right? Similarly, in this Swift, the way it describes holding up the printer on the same line is exactly the same format, but the language here in Swift, instead of end, it says terminator. So we will do that later. Okay. This is a text. Answer is colon, and then there is a backslash, and then parentheses. Backslash parentheses means altogether in Java programming language, for example, if there is a backslash, then there is escape character, which means um, this print statements ask printer to copy the text all the way here, the colon, but when it comes to backslash, then this statement tells the printer, hey, hold up, and this is I mean escape. Don't print this because it means something else. So in this case, it means, so backslash and open parenthesis, then it means, hey, the whatever in this uh, parenthesis, inside the parenthesis, this should be evaluated. Do not treat this as a simple text, but you need to print what this variable holds. How can you get the content which is held by a variable? That's the evaluation, which means we need to go back to the memory, see where here. For example, here, then if you say something, then I need to go back, say here, if I say number equals I lost all. What happens? Oh yeah. So number equals actually all here, but I want to do equals and then backslash within parentheses, then it gives you number equals from here to there, number equals backslash. When it comes to backslash, then printer get alerts. Hey, this is not something that treated as a text, but it means something else. So backslash followed by parentheses, that it means, oh, there's some variable needs to be evaluated. So number itself is evaluated. Okay, so evaluation of the variable means the content uh, uh, held by that variable. Okay, that's what it is. Well, we haven't explained this. Okay. All right. So another playground here is if we have a variable a, we say 5, a variable b, that is 1, and then a and b can be added, and then we can call that the total. And then we can make some conditional statements. If total is less than 20, then we can print whatever that is. So I want to practice that here. Okay, so let's close this, and then we can make some more room here. It's not possible to make only. Oh, this is okay. That's okay. So we can say variable a equals 5 and variable b equals 7 and variable total equals a plus b. All right, so we have a b. Okay, so total right now is 12, right? And after that, conditional statement. If total is less than, let's say, greater than 20, then we can say print we can say total is greater than 20, right? So this if statements is executed, evaluated, but it didn't appear here. Why? Because this print statements works only total is greater than 20. Total right now is 12, as you can see here. A is 5, B is 7, add them, then there is 12, which is not greater than 20. But if we add this A equals 15, when it comes to 15 here, A plus B, then there's 22. Therefore, 22 is greater than 20. This print statements is evaluated so that you can see the output of the print statements. All right, that's what it is here. And function can be also defined. The function, when you create a function, then it should be like a variable declaration, any variable, then you simply specify whether it is a variable or constant. Similarly, if it is a function, then at least you need to say there's a func, okay? And then the function name, it takes two variables and return integer, so it returns that. Okay, this is the function. The way that you can use is here, answer equals, and that function call, this is the function name, this is the name of function, and it is called here. The way you enter A and B, right? When you enter two values, then it comes here. That value is sent to this accordingly, two integers. Then within this function, what it does is that the first number is called num1, second number that is received by this function is called num2, and those two variables are added together, and then whatever the outcome of that addition will be returned, right? It is returned, then what it returned is assigned to this variable answer, and this answer is printed, as you can see here. All right, so let's try that. So let's try to define a function. Okay, there is a little tricky, but don't worry about it. Function call, actually, if we want to return, then we'll look at this a little further. But the way it appears here is not going to work as is, because it should have the variable, this is internal variable or external variable. If we do not want to specify external variable, then you need to simply say underscore. And this is the function definition. So internally, I want to take the first argument as fn, second argument as sn. I want to add them together and return to the caller. So caller receives that and print that out, right? So this is a function itself. This is external. So external, from the external caller side, the first parameter is 51 and second parameter is 71. Okay, so these two numbers are sent to the function. Then first parameter is taken as fn, second parameter is taken as sn, and add them and return. It's not a problem, right? But only funny thing is that you need to do underscore space fn and underscore space sn. If you do not have this, for example, then what happens here is that there's an error, right? Because it says playground execution fails, error, missing argument to label SN in call, because there is no label. There is no label, then you can say, oh, first label for the first parameter and label for the second parameter is missing by saying underscore and by saying underscore here. Then it should work, right? But if you do not want to underscore, then you need to say something. For example, external SN, and then here external FN. By having that, you need to say external FN is 51 and external SN is 71. In this way it works also, right? This 51 from the external, 51 is a value from external, but internally, from external, internally I would say, I would call it, I would hold it in this variable fn. Second one also similar to that. If you don't understand this function, that's okay, but this is a little tricky. This is not the case of other programming language. This is a little bit of a drawback, but that's okay, okay? Don't worry too much about that. Random variables also generated if you want to do random variable. For example, we will do that a little later, okay? So array can be declared very similar to other languages within square bracket, so that you have 10 numbers, and this is a variable that can hold the integers as an array, and then we can use it. Okay, if you want to do it, we can practice that also here. Variable array integer, type of that is int, and then initialize it by saying 1, 2, 3, 4, 5, and then if I want to print that and for loop, I want to I want to take each one at a time from that array int, and then print that x. So that I can print 1, 2, 3, 4, 5 from here. If I have more, for example 7, then I have here 1, 2, 3, 4, 5, 7. If I do not want to, for example 2 and 3, delete 2 and 3, then again 1, 2, 4, 7. This for loop is very similar to the for loop that you can find in Python. For each x in the list, I want to print that. This for loop also available in Java languages. Right? Java has similar to that also. If we want to do that, rather than this, if you want to do regular for loop, for example, for variable I equals 0, I is less than 5, and I want to increase I, and then print I. And here it should be 0, not number 1, right? So look at this. This is variable. If we want to do it similar to Java, then Java has this, right? Java usually have here, I want to do integer I equals 0, semicolon I is less than 5, semicolon I plus plus, and system.out.println of I. But that is not the case here in Swift. First of all, we don't need to do type for I, but simply say variable I. We don't need we don't need to put them in. We don't need to put those components in parentheses. Simply doing this and print. Therefore, we have print from 0 to 4. Okay, this is kind of a for loop. I want you to recall. So this is one type of for loop with 3 components. This is another type of for loop, which means for each element in the list, I want to do that. Okay, so I want you to practice this. Although I'm doing this so quick, but if you do not understand, then please pause this video and do some practice before you go. Proceed further. This is a little bit of languages and class definition and instantiation, and those are available. But other details we'll do further. A little bit of language. I want you to practice something that we did here. Okay, on this screen. This is enough for you could do for today. Let me close this so that you could have all of those. Okay, so I want you to do the work that we have been doing here, especially this for loop and here conditional statements. And function a little bit tricky, so don't worry too much about it. We do not do much of this, although we do. All the functions for iOS apps developments are pretty much auto created if it is not a lot simpler than this. Okay, hopefully you can practice this much before we meet next class. See you next time.